Let's explore the world of the binary coded decimal, often called BCD. BCD is a number encoding system. It is used to represent decimal digits using binary patterns. So, what exactly is binary coded decimal? In BCD, each decimal digit, ranging from 0 to 9, is represented by a 4-bit binary code. Let's look at the key features. BCD uses 4 bits for each decimal digit. It only utilizes the binary codes from 0000 to 1001. This means that the codes from 1010 to 1111 are considered invalid in BCD. Here is a table showing the binary coded decimal representation for each decimal digit. The decimal digit 0 is represented as 0000 in BCD. 1 is represented as 0001. 2 is represented as 0010. 3 is represented as 0011. 4 is represented as 0100. 5 is represented as 0101. 6 is represented as 0110. 7 is represented as 0111. 8 is represented as 1000. And 9 is represented as 1001. Let's go through a couple of examples to solidify your understanding of binary coded decimal. First, look at a single-digit conversion. If we have the decimal digit 7, it is converted to 0111 in BCD. Next, consider a multi-digit conversion. If we have the decimal number 95, it is converted to 1001 0101 in BCD. Note that each decimal digit is converted individually to its 4-bit BCD equivalent. Let's delve into BCD addition. Here are the essential rules to remember. First, add the BCD digits just like normal binary addition. If the sum is greater than 9, then you need to add 6, which is 0110 in binary, to the result. If there is a carry, it propagates to the next digit. Here's an example to illustrate BCD addition. Let's add 5 and 7. 5 is 0101 in BCD, and 7 is 0111 in BCD. Adding these two binary numbers yields 1100, which is 12. Since 12 is greater than 9, we need to add 6, which is 0110 in binary. This results in 0001, 0010, which represents 12 in BCD. Let's work through another BCD addition example. The problem is to add 38 and 47. The solution involves these steps. First, 38 is represented as 0011, 1000 in BCD, and 47 is represented as 0100, 0111 in BCD. Adding these two BCD numbers results in 0111, 1111, which is 70F in hexadecimal. Since F is greater than 9, we need to add 6, which is 0110 in binary, to the units digit. This results in 1000, 0101, which is 85 in BCD. Now let's tackle BCD subtraction. The method involves the following steps. First, use 10's complement to represent the number to be subtracted. Then add the complement to the minuend. Next, ignore the final carry if any. Finally, apply the BCD correction. Here's an example. 8 minus 3. 8 is 1000 in BCD, and 3 is 0011 in BCD. Subtracting 3 from 8 yields 0101, which is 5. Let's summarize the key points of BCD. The advantages of using BCD are easy decimal conversion, no rounding errors, and the ability to perform direct digit manipulation. However, there are disadvantages, including storage inefficiency, more complex arithmetic operations, and slower overall operations compared to pure binary representations. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.